Hello, hello. We continue building up our knowledge and skills of finding the area of triangle. It is Singapore Math, grade 5, first textbook, page 136. So take a look at this example number 3. Take a look at example number 3. We have area of triangle ABC, area of a triangle ADC, we have a triangle AEC, and all questions asking us to find these three triangles area. Step 1. Always identify the base. Let's consider triangle A, B, and C. Okay, let's consider this triangle first. The base is AC. Let's find the length. The length is, okay, 1, 2, 3, 4, 5, 6, 7. That's base. Base equals 7 units. Now, let's take a look at vertex. Let's find the vertex that is opposite of the base in triangle ABC, and that is vertex B. Now that we found the vertex, let's drop the height perpendicular to the base. And let's calculate 1, 2, 3, 4, 5, and the height equals 5 units. Therefore, let's find the area. 1/2 of base times height gives us half of 35, which is 17.5 square units. 17.5. Now, let's look at the next example. We have a triangle ADC. Again, let's consider for triangle ADC the same base. The base is the same. All triangles, in fact, share the same base, which is AC, and it's 7 units. Let's identify the height. First, find the vertex that is opposite of the base, and that's vertex D, and then drop the line straight to the base that is perpendicular. Guess what? This is our height, and it is also 5 units. Therefore, the formula to calculate its area is 1/2 of 7 times 5, which gives us 17.5 again. And finally, let's take a look at the third triangle, AEC. Again, let me create this. It's triangle A, E, and C, this slanted triangle. Now, the base is AC. We know it's 7 units, right? No surprises there. Something that we're used to now. Let us find the height correctly. Let's find the vertex opposite of the base. In this case, it's vertex E. Let's drop the height perpendicular to the base. Notice this particular height in this example is outside of the triangle. Perfectly normal. And when we calculate the area, is half of base, which is 7, times height, which is 5, again gives us 17.5 square units. What is so interesting about these three triangles is that they look different, but have the same area. Why? Because the height and the base are the same numbers, 7 and 5. Let's take a look at number 4. We have more examples. I'm going to solve B and D. Step 1, every time you're looking at triangles, it is very helpful to identify the base and height. Let's take a look at B. We have two choices. One of them can be base equals to 9. Okay? If base equals to 9, we're going to quickly find the vertex that is opposite of the base, and then we're going to drop a line down to the base. It's helpful to rotate your books. That is 90-degree perpendicular to the base. And the calculation will be very simple. Half of 9 times 12. Let's do commutative property, and we have 9 times half of 12, which is 6, gives us 54 inches squared. 54 inches squared. Next example, D. You know what's helpful for here is that I'm going to split this up like this into quarters, like that. Now, let's take a look at example D. What do we consider to be our base? Well, if you rotate the book, I do like this side. I like this side to be our base. And let's write it down, equals base. That is our base. What would be the height? Step 1, find the vertex opposite of the base. Here it is, I pointed it out. Drop the perpendicular line to the base with a 90-degree angle. That's what it means to be perpendicular. And we have the height conveniently located inside the triangle. All we need to do is do a straightforward calculation. Half of base times height. Let's find it. It would be half of 22 times 20 3/4. Half of 22 is 11 times 20.75. And my friends, I got 228 1/4 feet squared. I hope you found this exercise useful.